Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor, and today we're going to be talking about current division in circuits. Not many of you know how to do this, not many of you even know this exists, but basically what current division is, if I were to draw a sample circuit. And I have a battery connected to 3 resistors in parallel, and yes, it has to be parallel. Then I can use this concept called current division to find each current I1, I2, and I3 in each individual resistor. If I were to find the currents the normal way, I would have to remember that the voltage in all of these resistors is the same because they are all in parallel. And then I would use V equals I times R for each individual resistor to find their currents. And if you like doing it that way, that's absolutely fine. But I'm going to teach you a new way, which is very similar to voltage division, but now it's current division. So if you remember, voltage division is the voltage in, let's say, resistor 1 is equal to the battery voltage times R1 over the total resistance, R total. Also, this only works for series. Voltage division does not work for parallel. So in other words, I wouldn't even be able to use voltage division for this circuit because these are all in parallel. But current division is going to look very similar. If I want to find the current I1, it's going to equal the total current I total, which is the current, in this case, coming out of the battery. And then times, instead of R1 over R total, you just take the reciprocal, R total over R1. And this only works for resistors in parallel, not series. And obviously, I can do this for either I1, I2, or I3. And by the way, current division is not something that's such a powerful tool on its own. It's just another tool I have in my tool belt of possible options to easily find something like current in a circuit. So let's look at a couple examples today to practice current division. Here's the first one. I want you to find the current in all 3 resistors. Let's call it I1, I2, and I3. Your first step is not to use current division because you can only use that if they're all in parallel, which they're not. So then what do I do here? I would combine resistors. I would combine the 6 and the 12 using the equation 1 over 6 plus 1 over 12 to the negative first power, because that's how we combine resistors in parallel. And that'll get me 4 ohms. So then I'm going to redraw the circuit, and now I have 2 resistors in series. So one of the things I need in order to use current division is the total current coming out of the battery. So my advice is, if I want that current, I should be combining these resistors too, which are in series. That's just going to be 4 plus 4, 8 ohms. And then one more time drawing the circuit. So now I can use Ohm's law, V equals I times R, to easily find that current. Current's going to be voltage divided by R, which is 10 over 8. In other words, 1.25 amps. And so then going back to my original picture, I would say the total current coming out here is 1.25. I know that's going to equal I1 because currents that are in series are always the same. So I1 is going to be 1.25 amps. And now I just got to find I2 and I3. Let me just write these off to the side so it's easier to find them. Current going in is 1.25 amps. And then here's I2 and here's I3. And now I can just use current division. Watch how I do this. I2 is going to equal the total current, 1.25, times the quantity. Total resistance, that's the resistance of 6 and 12. Not the other resistor, not the 4 ohm, because that's not in parallel. I'm only counting these 2 in parallel, which is the same 1 over 6 plus 1 over 12 to the negative first power we did earlier, which is 4 ohms. So in other words, the total 4 goes in the numerator, and in the denominator is the resistor I'm looking at, which is the 6. So I plug that in a calculator, and we'll get 0.83 amps, and that's for resistor 2. Then for resistor 3, I'm just doing the exact same thing. Total current is 1.25, total resistance is still 4, but now it's just 12 because that's the resistor I'm looking at, and that's going to be 0.42 amps. And that's the current in I3. So maybe you like that method better, maybe you don't. If you wanted to use Ohm's law, V equals I times R, you would need to know the voltage going through both of these resistors, which is not the battery. It is not 10 volts, at least not in this case. So current division is not a bad way of solving this one. And now we just have one more circuit we're going to look at today. For this one, I want you to find all 4 currents through all 4 resistors, I1, I2, I3, and I4. So if you think you can do it on your own, just remember, we're combining resistors, finding the total current, and then using current division. And if you think you can do it on your own, go ahead, pause the video, and when you're ready to see the solution, unpause. Okay, so like I mentioned, the first thing we're going to do is combine these resistors one at a time. Don't do it all in one step. That's not going to work. So for the first one, it's in parallel. So 1/2 plus 1/4 to the negative first power. That'll be 1.33 repeating ohms. And then for the 6 and the 8, it's going to be 1/6 plus 1/8 to the negative first power. And that's going to be 3.43 ohms. So now I'm going to redraw the circuit. So I just have these 2 resistors here, the 1.33 ohm and the 3.43. And now I want to combine these again, because if I want the total current, I really just want one resistor, so I can use Ohm's law. So these are in series. It's as simple as addition. It's going to be 4.76 ohms. And one more time, redrawing the circuit. Now we get to say V equals I times R. Voltage is 15. Current is what we're solving for. And resistance is 4.76. So I divide both sides by 4.76. And we'll get 3.15 amps. Now in case you're forgetting why we're doing this, going back to the original picture, this is the total current coming out of the battery. In other words, this is the I total in the current division equation. And now when I look at I1 and I2, I can just start filling in. If I want to solve for I1, I total is 3.15. R total, I have to combine these two, which I did earlier. We said it was 1.33 repeating ohms, and then R1's just going to be 2 ohms. So then plugging this in a calculator, we're going to get 2.1 amps. That's I1. I2, I'm basically going to do the same thing. The only number we're swapping out is the resistance in the denominator, which is now 4 for I2. And that'll get us 1.05 amps. So I1 and I2 are accounted for. Now if I want I3 and I4, the total is still 3.15 amps. And I'm just doing the same equation. So I3 is going to be the total, 3.15, times the total resistance, which again we did earlier. I combined these in parallel and got 3.43, and then divided by resistor 3, which is the 6 ohm. Plugging that in a calculator, and we'll get 1.8 amps. And then finally for I4, it's just the same math, but replacing the 6 with an 8 in the denominator. And I plug this in a calculator, and we'll get 1.35 amps. And there we go. We found all the currents for this one, and so we're done the problem. So that's going to do it for this video. Thank you all for watching. If you have any questions, please post them in the comments. Hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.